Hey y'all, we're checking out the double angle formulas, actually how to use them. If you're interested in their derivation, check out the video on that. It's burly, but it's pretty neat. If you don't care about derivations, that's too bad. You should, because they're awesome. These are the double angle formulae. They're double angle because you have the sine of twice the angle. They're a little bit convoluted, but they have some interesting identities associated with them. And one of those is sine of 2 theta. You can call 2 times sine of theta times cosine of theta. And so you can use those interchangeably, which helps us solve some problems. Also, cosine has some interchangeable bits. Cosine of 2 theta can be called cosine squared of theta minus sine squared theta. Don't confuse this with the plus that equals 1. This is cosine squared theta minus sine squared theta. It has to be in that order. And you can do some things with this by substituting in sine squared theta in for this. You can get this, or substituting in cosine squared theta minus 1 for this piece, and you get this. So these two are offshoots of this main piece. They're in your formula booklet, or if you want to like tattoo them on your arm, that's cool too. Doesn't matter to me, but you should have them at your access. So here we go. Let's try to use them. We've got the sine of alpha is this piece, and we want to find the exact value of sine of 2 alpha. It's really tempting to just solve for inverse sine of 5/13 and find it that way. That leads you to some trouble. So let's check this out. This is another way to do it using the identities. You can first break this into, well, this is the textbook's way of saying cosine squared alpha, sine squared alpha should equal 1. They put in sine squared of alpha, which is 5 squared and 13 squared, right? And they solve by subtracting, and they get 12/13. That's one way to do it. I think an easier way to do it is say this is sine of alpha is the opposite over the adjacent. So opposite over hypotenuse. So the opposite will look like that, and the hypotenuse will look like that. This is 5, this is 13. I chose to write it this way, sort of backwards, because I know my angle is between pi halves and pi, so I know in my unit circle it's in the second quadrant. And so if you use Pythagorean theorem, this ends up being 12, but since it's in the second quadrant, it becomes negative 12. So the cosine of that angle is opposite over hypotenuse, negative 12 over 13. Doesn't matter to me how you like to do it, algebraically or graphically. I hope that you can see them both ways, though. So let's go with that. We're good with cosine of alpha is negative 12 over 13. We can take that and try to solve from there by saying, all right, well, I want the sine of, they asked us for the sine of 2 alpha. The sine of 2 alpha, we're going to use our identity to make this a little easier. We're going to use this identity and say, instead of calling it sine of 2 alpha, I'm going to call it sine of alpha, 2 times sine of alpha times cosine of alpha. I already know sine of alpha. They told me it's here. That's this piece. And then multiply by cosine of alpha, which I just figured out. It's this piece. So you have 2 times 5 times 12. That gives you this bit. And 13 times 13 gives you that bit. It's positive, positive, negative, so that gives you that bit. Fine. All right, just some mechanics. Let's try that again. So double angle formula, we know that alpha is acute. That'll help us determine between a positive and negative. We also know that cosine of 2 alpha double angle is 3/4. So we want to find the exact value of just regular old alpha. It's not half of this, which is unfortunate. But so we know that cosine of 2 alpha is 2 cosine squared alpha minus 1. Let's piece that apart a little bit. We know this piece, they gave us this piece. They said, here, cosine 2 alpha is 3/4, so throw it in. There it is. So we replace this with 3/4. Fine. We left the other side the same. Let's try to isolate cosine squared of alpha. That should look like this. If you take your 3/4. We've got to add 1 to both sides. Instead of calling it 1, I'm going to call it 4/4 because we've got to add to a fraction over there. Right, so this is plus 4/4. So -1 plus 1, these cancel out. And on this side we have 3/4 plus 4/4, 7/4. And then we'd have to divide by 2 or multiply by a half. Right, so really you have 7/8. So that's where this piece comes from. Great. And then we know that this is cosine of alpha squared, right? So to undo that square, you take the square root, right? So you'd square root this side, you get cosine of alpha, you square root this side, which means root top is the 7, and square root of 8 becomes 2 root 2. Because we're taking a square root, we can get possible positive and possible negative values, but they told us this is an acute angle, which means that, and they also told us that this cosine is positive. So it's an acute angle, which means it's not past 90 degrees. So it's somewhere in here. It's also positive, so that puts it squarely in Q1, which means that we're taking the positive value for the cosine. So we take the positive part, and that's that solution. Neat. All right. Last two. Give it a shot. Either pause me and try it on your own, or walk through with me. You can try this piece. We're trying to solve for x. We're going between 0 and 2 pi inclusive. This inclusive piece is important later on. And so this looks pretty ugly. There's a couple of things you can do with it. You could factor out a sine of x. This is 2 times sine of x plus another sine of x. So if you pull out a sine of x, you're left with this interior bit. This is just like quadratic, like x plus 2 and x minus 3 equals 0. If two things multiplied together give you 0, then either this equals 0, right, and you get -2, or this equals 0 and you get 3. This is the same sort of thing. And so we say, well, either sine of x equals 0 or this mess equals 0, right? Let's maybe walk through that a little slower. So I hope that this part's okay. Either this part is equal to 0, that's this, or this part is equal to 0. So either 2 sine x plus 1 is equal to 0. Subtract a 1, right? So 2 sine x equals -1, and divide by 2. Right, divide by 2. These cancel out. You're left with sine of x equals -1/2. That's where this piece comes in. All right. So there we have some sine values. It's either sine of x is 0 or sine of x is 1/2. Let's figure out where that happens as you go around twice. For just the sine of x equals 0, the sine of x is the y value. So 0 is included, so it happens at 0. That's this one. As you go around, the sine is the y value, so that happens again at pi. And it happens again at 2 pi. So there are those pieces. If you do this again with the half portion, this part, -1/2, the sine is -1/2, the y value, when you have this 30-degree triangle here. So it's less tall than it is long, if that makes sense. It's down below the x-axis because it's negative, and so this should be 6 pi sixths plus another 30 degrees, which is pi sixths, so 7 pi sixths. That also happens on the other side reflected, which is a 30-degree triangle or a pi sixths triangle, but below the x-axis. So at 7 pi sixths and 11 pi sixths. So we have 5 answers, 1, 2, 3, 4, 5, and that's why you see many of them there, because you get 2 possible solutions from here. Try that same thing with this. Factor out the cosine and try to clean it up. I'll show you my solution in a second. Okay, so let's clean this up a little bit. Let's factor this. If you look at this with your nerd goggles on, let me move this whole thing over. There. If you look at this with your nerd goggles on, you can think about this whole thing as 2y squared plus y minus 1 equals 0, right? Just treat cosine like a y, right? This would be y also. So this you could factor into 2y minus 1 and y plus 1, right? The 2y and the y would give you 2y squared. This would give you this, and here you get positive 2y's minus a y would give you that. Okay, not a problem, but it's not y, it's cosine of x, right? We just tried to substitute it in to make it a little more visually appealing. So this is 2 cosine of x, they used x, right? Minus 1, and cosine of x plus 1. Great, and those should equal 0. So now we can play the same game. Either this one equals 0 or that one equals 0. So if this one equals 0, then 2 cosine x minus 1 should equal 0. So add the 1, divide by 2, so cosine of x is a half. Or cosine of x plus 1 is 0, so cosine of x should be negative 1. Cool, so those are our two possible cases. So from there, we can pick one of them, say, okay, when is cosine a half? And that happens at pi thirds. Because we're going all the way to 2 pi, there's another value. It's positive a half, so that happens all the way over here again, and that's 5 pi thirds. So there are two solutions for that. Also, when is cosine of x negative a half? Well, that only happens once. Right? That only happens back here at pi. So you only get one solution for that. So we get two solutions from the top, one solution from the bottom, 3 solutions in total. And we're solutioned out. Cool. See ya.